Hello everybody. The rest of the part of the inverse trigonometry. So first of all we will discuss about the properties. So first is there sine inverse sine x is equal to x. But this x must belongs to minus pi by 2 to plus pi by 2. But if it is sine inverse x is there, it will be equal to x. But if x belongs to minus 1 to plus 1. So this is one of the case you must remember. Similarly, if we talk about the cos inverse cos x is equal to x if x belongs to 0 to pi in closed interval. But cos inverse x is equal to x where x belongs to minus 1 to plus 1. Similarly, you can take for the cot and sec. Here is similarly for cosecant inverse. This is your cosec inverse cos x and cosec inverse x is equal to this one. Now the second property is, just you can go through these properties in first. Second one is there, sine inverse x is equal to cosec inverse 1 over x. But the condition is either x should be greater than equal to minus 1 or it is less than equal to plus 1. Similarly, cosec inverse x will be equal to sine inverse 1 over x if x is less than equal to minus 1 or x is greater than equal to plus 1. Just see, now you can compare. This is the way to remember. Here is x is less than equal to 1. In case of sine is going to change in cosec. But in case cosec to sine, x is greater than. Less than is going to become a greater than. Here is greater than, less than. But in case of the tan inverse x is equal to cot inverse 1 over x if x is greater than 0. But if your ax is less than 0, then it will be equal to minus pi plus cot inverse 1 over x. This is the one of a special case you can take. Similarly, in case of the cos inverse x is equal to sec inverse 1 over x, but x is greater than equal to minus 1 or x is less than equal to plus 1. Sec inverse x is equal to cos inverse 1 over x if x is less than minus 1, just opposite of this one, and x is greater than equal to plus 1. In the same way, in case of the cot inverse x is equal to tan inverse 1 over x if your x is greater than 0. If your x is greater than 0, then in place of cot inverse x you can write down tan inverse 1 over x. But if your x is less than 0, then cot inverse x will be equal to pi plus tan inverse 1 over x. So these two properties have a look. Okay, now the property third, sine inverse minus x is equal to minus sine inverse x where x is greater than equal to minus 1 but it's less than equal to plus 1. Similarly, tan inverse minus x is equal to minus tan inverse x, cosec inverse minus x is equal to cosec minus cosec inverse x in this one. So this is already, we know that these three are in one group. Sine inverse x, sine inverse, tan inverse and cosec inverse, they are in the same group. This is already we discussed. If we take this is 0 to pi and this is minus pi by 2 to plus pi by 2. In third quadrant nothing, and here is the minus pi to plus pi by 2, sine inverse, tan inverse and cosec inverse, and 0 to pi here to here is cos inverse, cot inverse and sec inverse. So these are three in same group. So the way to remember this one is minus sine inverse x minus. But in case of the cos inverse minus x, that is equal to pi minus cos inverse x. Sec inverse minus x is equal to pi minus, and cot inverse minus x is equal to pi minus cot inverse x. So these three are in same group. So this is the way to remember pi minus, these three, and these three is direct minus is there. But here is the very important concept is here. This cos pi plus theta, that is always equal to minus cos theta. This is already, you know that. This is your x-axis and y-axis. So this is pi minus theta and here is the pi plus theta. So if cos pi plus theta in the third quadrant, we know that is, this is your minus cos theta is there. So what exactly we want to say is here, cos pi plus theta is equal to minus cos theta. but minus cos theta cannot be written equal to the cos pi plus theta, even though then cos pi plus theta is equal to minus cos theta, but minus cos theta cannot be written. Why we cannot write? Because here you are in the third quadrant is there. One more point, if we assume that cos pi plus theta is equal to x, so what will be your cos inverse x will be equal to pi plus theta, but the value of this cos inverse x is lies between including 0 to pi, including 0 to pi. But here is you are getting what? Cos inverse x equal to pi plus theta. It means the principal values already we know that, but this cos inverse lies this one. It means in the above case, this condition will not be satisfied. Here you can take here only. Here should be pi minus, but here is the pi plus, because theta is equal to is this is the angle, because here should be pi minus. So cos inverse x is equal to pi plus theta, but this cos inverse is lies between here 0 to plus pi, 0 to plus pi, but here something we are going to add. It means we are going in this one, and this is already you know. In case of the inverse, nothing is here in the third quadrant. This is already we know that. So have a look. Okay, now the property 4. Property 4 is sine inverse is equal to cosec inverse 1 over x. But this sine inverse is equal to cosec inverse 1 over x in case either is x is greater than equal to minus 1 or x is less than equal to plus 1. Then sine inverse x is equal to, you can write down cosec inverse 1 over x. Similarly, cosec inverse x is equal to sine inverse 1 over x. This is going to change. Here is x is greater than equal to minus 1, but now it's become x is less than equal to minus 1. X is less than equal to plus 1. Now it's become x is greater than equal to plus 1. So these two are, you can remember these two together. Similarly, in case of tan inverse x is equal to cot inverse 1 over x. But if your x is greater than 0, but if your x is less than 0, then the tan inverse x is equal to minus pi plus cot inverse 1 over x. This is, keep in mind, this tan inverse minus x will be equal to minus pi plus cot inverse 1 over x in case if x is less than 0. Similarly, you can remember these, cosec inverse x is equal to sec inverse 1 over x if x is greater than equal to plus minus 1 or x is less than equal to plus 1. Sec inverse is equal to cos inverse 1 over x. Just you can avoid it. This is x is less than equal to minus 1 or x is greater than equal to plus 1. So you can remember these two together. Similarly, in case of the cot inverse x is equal to tan inverse 1 over x if it is your x is greater than 0. But if it is less than, it will be pi plus tan inverse 1 over x. Property 5 is sin inverse x plus cos inverse x is always equal to pi by 2 if x belongs to minus 1 to plus 1 in closed interval. Similarly, tan and cot inverse is equal to pi by 2. Cosec and sec is also equal to pi by 2, but its modulus x is greater than equal to plus 1. This is your very important properties. Property 6. Tan inverse plus tan inverse y is equal to tan inverse x plus y over 1 minus xy. But the condition is x and y both are greater than 0 and product should be less than 1. This is the very important point is here. This one. This is the very important point. This is the condition must be satisfied. Then only you can apply. But if your x and y both are greater than 0 but the product is greater than 1, means instead of the xy is less than 1, यहाँ क्या है xy का product 1 से कम है. But if your x and y product is comes greater than 1, then this tan inverse x plus tan inverse y will be equal to pi plus tan inverse x plus y over 1 minus xy. But if the product of xy is equal to 1, then it will be equal to pi by 2 only. X and y both are less than 0 and but the product is greater than 1, then it will be equal to minus pi plus tan inverse x plus y over 1 minus xy. But you must remember this is the property which is already given in on NCERT. और one important point is keep in mind कि जब बोर्ड में हम we are giving the solution तो आप कोशिश करिए कि you must use the identity properties which are given in on NCERT is there only for the marks की point of view से. So you must remember this one, this with this condition, both are greater than equal to greater than 0 but product is less than 1, then you can write down this one, otherwise pi plus it will be equal to pi by 2 if it is the product of xy is equal to 1. So have a look. Yes. Now similarly, the property 7 is there. Tan inverse x minus tan inverse y is equal to tan inverse x minus y over 1 plus xy, where x is greater than 0 and y is greater than, but the xy should be greater than equal to minus 1 is there only. See. Similarly, this is pi plus tan inverse x plus y over 1 minus this condition. These are there. Similarly, you can go for the property 8 sin inverse x plus sin inverse y is equal to sin inverse x and root 1 minus y square plus y. The way to remember is this x under root 1 minus y square, this y under root 1 minus x square. This is the way to remember. But the condition is there, xy product is less than 0, but the sum x square plus y square must be greater than 1. This will be equal to pi minus sin inverse. If these conditions are going to satisfy, it will be equal to minus pi minus sin inverse if these conditions are going to satisfy. Similarly, property 9 sin inverse x minus sin inverse y is equal to sin inverse x minus, here this both are same, only the sign is going to change. Here is the plus, then here become a minus is there. Xy is greater than 0 and x square plus y square is greater than 1 is there. This is going to satisfy, this is equal to, in case if this is pi minus, if this is the condition is going to satisfy. So have a look. Okay, now next property is there. If 2 tan inverse x is equal to tan inverse 2x over 1 minus x square, condition is if x is greater than minus 1 but it is less than plus 1, it will be equal to pi plus 2 tan inverse 2x over this one if it your x is greater than 1. Similarly, in case the 2 tan inverse x, in terms of the sin inverse 2 over 2x over 1 plus x square, if it is x is greater than equal to minus 1 but it's less than equal to plus 1. But 2 tan inverse x, in case of the cos inverse 1 minus x square over 1 plus x square, but if x is greater than equal to plus 1 but less than infinity is there. So these are the conditions 2 tan inverse in case of the tan, sin and cos. So have a look. Yes. Now sin inverse x in terms of cosec, that is cosec inverse 1 over x, is also sin inverse x is equal to in terms of cos, will be cos inverse under root 1 minus x square. Sin inverse x is equal to tan inverse x over under root 1 minus x square. Similarly, cot inverse under root 1 minus x square over x, and sec inverse 1 over under root 1 minus x square. Just see now, cos and sec, just here is together remember, and cot and tan is here. So sin inverse can be written as in terms of cosec, cos, tan, cot and sec. Similarly, cos inverse x can be written as in terms of sec, sin, tan, cosec and cot. And tan inverse x also can be written as cot inverse, sin inverse, cos inverse, cosec inverse, sec inverse. These are the very important formulas which we required later on, which we will use in the questions only. So go through, have a look. Okay, now we are taking the problem. First problem is prove that 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse 31 over 70. See, here is the 2 tan inverse x. We know the formula for tan inverse x, which easily we can apply. Tan inverse y is equal to tan inverse x plus y over 1 minus xy. But by condition is there, xy should be, product should be less than 1. So one way is there, you are supposed to write this 2 tan inverse x in terms of tan. So this is already, we know that 2 tan inverse x is equal to tan inverse 2x over 1 minus x square. So if you can change, this is in terms of tan inverse x only, then we can apply tan inverse x plus tan inverse y is there. So we are supposed to change this one. So in place of this one, we can write down what? Tan inverse 2x, 2 into x is 1 by 2 over under root sorry, 1 minus x square, that is 1 by 2 whole square, and keep this term as it is, 1 over 7. Because we know that tan inverse x plus tan inverse y is equal to this one, not 2 tan inverse x plus tan inverse y is not equal to tan inverse x plus y over 1 minus xy. So here you will get, this is your tan inverse 1 over, this is 1 minus 1 by 4, so that is 3 by 4, plus tan inverse 1 over 7. This is tan inverse, can be written as 4 over 3 plus tan inverse 1 over 7. Now here you can check the product of these two, means 4 over 3 into 1 over 7 is equal to 4 over 21, which is less than 1. It means we can apply this formula because the product is less than 1. So now this can be written as tan inverse x is 4 over 3, y is 1 over 7 over 1 minus x into y is 1 over 7. So this is can be written as tan inverse. You can take the LCM, 24, 28 plus 3, 31 over 21, and this is your 21 minus 4, that is 17 over 21. This 21 cancelled, so this is equal to tan inverse 31 over 17, which is equal to the RHS. This is your proved this theorem. Have a look. Okay. Next question is, show that sin inverse 5 over 13 plus cos inverse 3 over 5 is equal to this one. See, this question we can solve if we can change the cos inverse in terms of the sign, then you can apply the sin inverse x plus cos sin inverse y. This is also one of the formulas, sin inverse x plus sin inverse y. You can, or if you can change the sin inverse 5 over 13 in terms of cos inverse, then you can apply cos inverse x plus cos inverse y. Another is there, if we can change this sine and cos both in terms of tan, then we can apply this one, tan inverse x minus tan inverse y. So we have the three options, but because on the right hand side on your RHS this is given tan inverse, it means we are supposed to try to change these two in terms of tan instead of sine and cos. Just see how can you change. You can, your left hand side is this one, you can assume that x is equal to sine inverse 5 over 30. Just simply you can, but this can be written as sine x is equal to what? 5 over 30. Now what we will do, just see, as usual, just take a right angle triangle. Let this angle is, we are taking x, so this is perpendicular over base, perpendicular is 5 and base is, sorry, this is perpendicular over hypotenuse, this is 5 and this is 30. Now the Pythagoras theorem, by applying the Pythagoras theorem you can find out this one. So what about this one? It will be equal to 12, because 13 square means 169 minus 25, 144, that is 12. So from here you can find out the value of tan x. So tan x is equal to, what will be there? 5 over 12. So from here you can say that x is equal to tan inverse 5 over 12. It means what you are getting, because already we assumed x is equal to this one, so x is also equal to tan inverse 5 over 12. So it means tan inverse 5 over 12 is equal to sine inverse 5 over 13. So this is already changed in terms of tan. Similarly here you can do, now you can assume that y is equal to cos inverse 3 over 5. So here is the cos y is equal to 3 over 5. So similarly you can do, look at here now, you can take the right angle triangle. Let this angle is x, so this is base over hypotenuse, base is 3, hypotenuse is 5, so this is your 4, 25 minus 9, 16, this is 4, this is right angle. So from here you can find out the value of tan x, so tan x is equal to what? 4 over 3, so this is x is equal to tan inverse 4 over 3. So as we were getting x equal to this one, that was also equal to the sine inverse 5 over 30. Similarly, this is x is equal to tan inverse 4 over 3 is equal to cos inverse 3 over 5. So in place of cos inverse 3 over 5, you can write down this one. In place of sine inverse 5 over 13, we can write down this one. So finally what we are getting is here. Now look at here. I'm going to rub this one is this. So this is your tan inverse 5 over 12 plus, and this is tan inverse 4 over 3. So now again look at here. You should be very careful. The sum, the product of this and this one should be equal to less than 1. So here the 5 over 12 into 4 over 3. 4 3, so this is 5 over 9, which is already less than 1. So you can apply the tan inverse x plus tan inverse y. So that is equal to what? Tan inverse x plus y, that is x. I'm taking 5 over 12 plus 4 over 3 over 1 minus 5 over 12 into 4 over 3. So this is equal to tan inverse, you can write down, this is 36 you can take, that is 15 plus 48. So this is 63, and here is 36 minus 20, 16 over 36. So you can cancel. So finally you are getting, that is tan inverse 63 over 16, which is your right hand side. Have a look. Yes. Now the question is, if tan inverse 2 and tan inverse 3 are the two angles of a triangle, then find the third angle. You have to find out the third angle. What exactly the question is saying? Question is saying there is a triangle. We can have a triangle. Just if we talk about the solution, a triangle. You can take like ABC. So in this triangle ABC, like I am taking here, and you can take C is here. In this triangle ABC is there, and angle, the two angles are given. Means for the one convenience you can say angle A is given, which is equal to tan inverse 2, and angle B is equal to tan inverse 3. So you can assume that A is the angle which is equal to tan inverse 2, and B is equal to tan inverse 3. See, now you can say like this angle is given 30 degree or this is given the 70 degree. We have to find out the third one. So instead of the angle, this is given in terms of the inverse is there. So angle A is tan inverse 2, B is this one. We are interested in third angle, that you can say here the angle C. And this is already we know angle A plus angle B plus angle C is equal to 180 by the angle sum property. This is already we know that. So angle A is nothing else, that is tan inverse 2. Angle B is tan inverse 3 plus C is equal to pi. We are interested in angle C. So what will we see here? C will be equal to pi minus, you can transpose tan inverse 2 minus tan inverse 3. And this can be written as pi minus, you can take out the common. So this is here is tan inverse 2 plus tan inverse 3. This is there. Now here we can apply the tan inverse x plus tan inverse y. But here the most important point is here only. See, the most important point is here. The tan inverse x, I am going to write here, tan inverse x is equal plus tan inverse y is equal to tan inverse x plus y over 1 minus xy, in case if the xy is less than 1. But here is x is 2, y is 3. So 2 into 3, that is 6, which is not less than 1. This is the important point, is here only. because already we know that product of these two must be less than 1. But here is the product is not less than 1. It means this will be equal to pi minus. This is equal to, in case of xy is not less than 1 but xy is greater than 1, then this is equal to pi minus tan inverse x plus y, 2 plus 3 over 1 minus 2 into 3. In case if the product of x and y is not less than 1, if it is greater than 1, then that is equal to pi minus tan inverse, that is pi minus will be there only. This is already discussed is there, sorry, not pi, plus is there. This is already we discussed in a formula. So this can be written as pi minus tan inverse, and if you will solve this one, so this is 2 plus 3, 5 over 1 minus 6 minus 5. So this is 5 over minus 5. Pi you can cancel. So you will get here is minus tan inverse minus 1. And this is equal to tan inverse 1. That you can write on, tan inverse 1 is there only. And this is equal to tan inverse, and value of the 1 is tan pi by 4. So this is equal to pi by 4. Because this pi by 4 is already belongs to the principal value is there only. So therefore, the third angle C is equal to pi by 4.